with this methodology. I would like to then...
I have just given a talk at the Nanospace ECOS meeting in Kaunas, titled Diamondoid Stability After Ionization. I told everyone about our general procedure of studying molecular fragmentation and shown two examples, furan cation and adamantane dication. One is a proof of concept, and the other one was a natural follow-up of the first one. I briefly talked about importance of studying diamondoids and adamantane specifically. So I explained a little bit about the structure of adamantane, about its carbon cage and how stable thermally it is. Because of its structure, it's expected to be abundant in the interstellar medium. That's why it's interesting to this community, I think. But I draw attention to the fact that there is some discrepancy between the measurements in the laboratory and the astronomical observations that we have. There is deficiency of adamantane in astronomical observations. So the natural question is why is it true? Why we don't see as much of adamantane in the interstellar medium? One of the answers might be that it is ionized and then it fragments. Before I have shown some results, I wanted to explain our methodology a little bit more. So I have said I presented our methodology and focused on our statistical theory called microcanonical metropolis Monte Carlo, which we call M3C. This methodology, using this methodology, we obtain breakdown curves. When we obtain them theoretically, we of course can compare them with experimental measurements obtained with a PEPICO technique. It's a photoelectron photoion coincident measurements, and this we obtained quite a good agreement. That's why our suggestion was that the main factor guiding the fragmentation is the amount of energy transferred into the system, and also the conclusion was that it's in line with the assumption that the energy is redistributed randomly between available degrees of freedom. And when speaking about adamantane, I talked about what are different isomers of adamantane dication. I have shown some pictures of it. We saw that its ionized version has an open cage, and this cage opening is a very interesting process which we can study with molecular dynamics and with potential energy surface exploration. And then I showed some curves which led us to the conclusion that cage opening is barrierless. And for the fragmentation process, I have shown some molecular dynamics results which when considering vertical ionization was not a very abundant process. However, when studying fragmentation with our statistical theory, there we start with global minimum. The fragmentation was already reached, and we saw quite a lot of fragments being produced. This was in line with our hypothesis that the fragmentation would be reached of this specific diamondoid example. Yeah, and that's it. That was our connection between the hypothesis and our results.